Hey guys, welcome back. Happy New Year. Today is day 37 and we're going to learn how to graph inequalities with two variables. So you should first start by looking at the warm-up that's in Schoology and try to complete that. You can pause this video, but now we're going to go over the warm-up. So if you remember, an inequality looks like an equation, but instead of an equal sign, we can have a greater than symbol or greater than equal to, or we could have a less than symbol or less than or equal to. Okay, so earlier this year, we learned how to graph an inequality with one variable. So in looking at number one, you'd start out and you distributed it. So you get negative 10 plus n is greater than or equal to negative 30. All right, and then I would add 10 to both sides to get n by itself. So n would actually be greater than or equal to negative 20. All right, so if I graphed it on a number line, if this was 0, this would be negative 20. Remember, since it's greater than or equal to, I would make a circle and then I would color it in because of that equal sign. And greater than would be all the values to the right. Okay, so any of the values above that line, including negative 20, would satisfy that inequality. All right, if I look at number two, we're going to start out and we're going to, just like we solve an equation, we're going to distribute first, okay? So I've got negative 5n plus 6 is greater than or equal to negative 35n plus 42 minus 6n. Okay, so I started out and now I'm going to combine my like terms. So when I do that, I've got negative 5n plus 6 is greater than or equal to, and this is going to be a negative 41n plus 42. All right, so now when I add 41n to both sides, all right, I'm going to get a positive 36n plus 6 is greater than or equal to 42. And then when I subtract that 6, I end up with 36n is greater than or equal to 36. My final step, I divide both sides by 36, and n is actually greater than or equal to 1. All right, so if I had a number line, if this was 0, 1 would be to the right. And because it's greater than or equal to, I would color it in, and it would go to the right. Okay, so looking at in class, we went over any homework questions, all right, but then moving on to 37A. So this is what we're covering today. All right, so graphing a linear inequality in two variables has an ordered pair that produces a true statement when the values of x and y are substituted into the inequality. Because inequalities are going to have an infinite number of solutions in a certain area, we're going to find out. So we want to see which ordered pair is not a solution. So to determine this answer, we need to substitute in each of these ordered pairs and then see which one would be not a solution. Okay, so I'm going to start out, and with A, I'm just going to take x, so it's going to be x minus 3y is less than or equal to 6. So that's the inequality. I'm going to plug in that 0 is 0. So when I do that, I get my 0 is my x minus 3 times 0. Is that less than or equal to 6? I end up with 0 is less than or equal to 6. So that's a true statement. So that's a yes. All right, that's a solution. That would work. Okay. Now if I took B and I plugged them in, again I've got x minus 3y is less than or equal to 6. If I plugged in my x, which is 6, minus 3 times negative 1, is that less than or equal to 6? So when I do this, I get 6 plus 3 less than or equal to 6. Well, 9 is not less than 6, so this is going to be a no. All right, I'm going to do the same things for C and D. So I'm going to take the ordered pair 10 and 3. And again, I've got my x minus 3y, only now I'm plugging in 10 for my x, minus 3 times 3, is that less than or equal to 6? 10 minus 9, well, I get 1. That one's actually true, so this is a yes. That's a solution. All right, and then the final one, D, when I plug in negative 1, 2, I've got x minus 3y is less than or equal to 6. So my x is negative 1 minus 3 times 2. Is that less than or equal to 6? Negative 1, so negative 1 minus 6 is less than or equal to 6, or negative 7 is less than or equal to 6. So this one's true, so that's also a yes. Okay, so the only one that's no is B. Okay, so the ordered pair that is not a solution would be 6 and negative 1. All right, so why don't you pause the video and try this next example. Tell whether the ordered pair is a solution of negative x plus 2y is less than 8. All right, I'm going to go ahead, hoping that you continue the video and check it out. So I've got a negative 0. Never seen a negative 0, but I'm going to write it there. There's no such thing as a negative 0. It's just 0. Plus 2 times 0, is that less than 8? Okay, well, this becomes 0 is less than 8. All right, in that case, that's a true. So that's yes. All right, so we're looking to see if it's a solution. For B, I plug in 0, 4. So I've got 0 plus 2 times 4. Again, this time I didn't put that negative in because we know it's not a negative 0. Is that less than 8? Well, I end up with 0 plus 8 is less than 8. 8 is less than 8. Well, 8 is actually not less than 8. It's less than or equal to 8, but it's not less than. So this one actually would be no. All right, so far A is a solution, B is not. Let's look at C. So C, we've got negative x, so C would be negative 3 plus 2 times 5, is that less than 8? Negative 3 plus 10, is that less than 8? 7 is less than 8. That is true. So that's a solution as well. So in that example, A and C are both solutions. All right, so we want to start to graph linear inequalities. Before we graph, there's two important things you recall. So if you remember, the inequality is less than or greater than. Notice there's no equal sign. The line of the graph, okay, is going to be dashed. Like when we just had a had it on the open, we had it on a number line. We said it was an open circle. Now we're going to be graphing a line. So we're not going to have an open circle. Instead, we're going to have a dashed line. Okay, but if the line of the graph has that equal sign, so less than or equal to or greater than or equal to, in that case, the line of the graph is going to be solid, just like we've been making for linear equations. Okay, so the procedure to follow is step 1. We always have to rearrange the problem into slope-intercept form. That just makes it easier to graph. Okay, so we can identify the slope and the y-intercept. And that makes it easy to graph. So we graph the linear inequality. Make sure the line is either solid or dotted, all right, or dashed, okay? So dotted or dashed, okay, accordingly, okay? And then we have to color. We're going to shade one side of the line. So we like to use a test point, okay? Maybe use 0, 0 to determine which side of the line to shade, okay? And the shaded side represents all of your solutions. All right, so however, you may not pick a test point that falls on the line. So be careful. If 0, 0 happens to be on the line, pick another test point like 1, 1. All right, and then we shade the graph, and then we check the answer on Desmos. Okay, Desmos is great for checking inequalities. Okay, so let's look at the first example we have here. So the first example, we've got y is greater than 4x minus 3. All right, so the first thing I'm going to do, it's already in slope-intercept form. I know my slope is 4 and my y-intercept is negative 3. All right, so to graph this, I start at negative 3 for my y-intercept right here. Okay, and I notice it's just greater than. So that means it's going to be a dashed line. All right, so I'm going to say dashed line right there because I know it's just greater than. So since my slope is 4, I'm going to think my rise over run. So I'm going to go up 4, 1, 2, 3, 4, and over 1. Okay, or I'm going to go up 4, 1, 2, 3, 4, and over 1. All right, and I'm going to do the same thing. Okay, now I'm not going to connect the points with the solid line. I'm going to make a dashed line. So it's going to look something like this. Okay, there's my dashed line. Okay, now I need to have a test point. Okay, I need to know which side of the line to shade. Since y is greater than 4x minus 3, okay, I'm going to test the point 0, 0. All right, what I mean by the testing the point 0, 0, there's 0, 0. Notice it's not on the line, okay? If I take that test point and I put in 0, 0 into the inequality, y is greater than 4x minus 3, this is going to be 0 is greater than 4 times 0 minus 3. I just plugged in my x and my y values. So 0 is greater than negative 3. Well, that's a true statement. Okay, because it's true, we want to shade the part of the graph that includes 0, 0. All right, so that means that when I go to shade, all right, I'm actually going to shade the part that includes the 0, 0. So I'm going to shade all of the ordered pairs that includes that 0, 0 region, just like that. Okay, what that means is that any ordered pair in that region that we shaded, that would be a true statement. That would be a solution to the inequality. Okay, so let's try the next one. We're going to graph the inequality. X plus 2y is less than or equal to 0. First, I need to put it in slope-intercept form. So I'm going to start by subtracting x from both sides. When I do that, I get 2y is less than or equal to negative x plus 0, but I'm not going to worry about writing plus 0. And then I'm going to divide both sides by 2. So y is less than or equal to negative 1/2 x. Okay, so we have that, and from here I can identify my slope as negative 1/2, and my y-intercept is 0. Okay, so in this case, we're actually going to start at the y-intercept, which is 0, 0. And our slope is negative 1/2, only I'm looking at this right here, and I notice that's going to be a solid line, okay, because it's less than or equal to. All right, so that's going to be our solid line. So my slope is going to be negative 1/2, so I'm going to go down 1 and over 2. All right, or I'm going to go up 1 to the left 2 like that. Okay, it looks like this. I make my solid line like this, okay. And now I need to shade. Now notice, I can't test 0, 0 because it's right on the line. All right, because if it comes up true, I'm not going to know which side to shade. So I'm going to pick a different point. I'm going to pick the point maybe 1, 0. So I'm going to say, I'm going to take the point 1, 0 right here. Okay, let's make this blue so it sticks out a little bit more. There it is. All right, so I'm going to test the point 1, 0. All right, so when I test 1, 0, I plug in the value, and I've got I'm going to put in 1, 0. It doesn't matter if I put it into this form or this form, but I'll put it into the slope-intercept. So I'm going to test 1, 0. So my y is 0. Is that less than or equal to negative 1/2 times my 1? All right, so is 0 less than or equal to negative 1/2 times 1 is going to be negative 1/2. All right, well, that's false, okay? So because it's false, 0 is not less than this. That means we're not going to shade the side that has the 1, 0. Instead, we're going to shade the other side, okay? So we're going to shade this side. If it was true, we would have shaded the side of the line that had 1, 0. All right, and in both cases, you can go into Desmos and you can put in the inequality and you can see which side is shaded to check it out. All right, so let's look at our special cases. All right, again, now we've got y is greater than or equal to negative 3. I'm going to think of, I'm going to think of HOI. It's a horizontal line. All right, so y is greater than or equal to negative 3. So that means when my horizontal line at negative 3, 1, 2, 3, if you notice, this is going to be a solid line. All right, I'm going to make that horizontal line. And actually the special cases are a little bit easier because we know it's greater than or equal to negative 3. So it's going to be anything above or greater than negative 3. We can also test out 0, 0 if we want to. Okay, but I find it's easier just to think of greater than is above the line, less than is below the line. Okay, so when we actually do this, it's going to be everything shaded up here. Okay, but if we did that test point, say we decided to test out that 0, 0, if we put in 0, 0, we would have 0 is greater than or equal to negative 3. And that's true. So notice that 0, 0 is in the region that's shaded. Okay, so now we've got a vertical line, okay, because we have x is less than or equal to negative 1. So our negative 1 is going to be right here. And in this case, this is going to be a solid line again. All right, so I'm going to make that vertical line, and not very straight, okay? But x is less than negative 1, so if you think of the x as a number line, anything less than is going to be to the left, okay? So we're going to shade that, but let's go back to testing our point too. Oops, let's get that, there we go. So we're shading on this side. All right, but we're going to test the point 0, 0. So if I put in 0, 0, I would end up with 0 is less than or equal to -1. Well, that's false. Okay, so if you notice with 0, 0, because it's false, we're not shading that side of the line. We actually shaded the other side. So it works both ways. Okay. All right, so I want you guys to try for me number 7. You can pause the video and try it, or I'll just go ahead and do it. All right, the first thing I want to do is put it into slope-intercept form. I'm going to do that by subtracting 2x from both sides. So 4y is less than -2x plus 8, and then we divide by 4. So our y is going to be less than -1/2 x plus 2. All right, so to graph it, my slope is -1/2, and my y-intercept is 2. So I'm going to start at my y-intercept of 2, and my slope is -1/2. So I'm going to go up like this. It's going to go down, down 1 over 2. Okay, again, in this case, all right, it's going to be a dashed line. Okay, if you notice, because it's just less than, so that's going to be dashed. All right, so I'm going to connect these points, but I'm going to up 1 and over 2. So a little, there we go. All right, so it's going to look something like this, dashed line. Okay, all right, I'm going to use the test point of 0, 0 right here. All right, and I'm going to put that in. Okay, and when I do that, test 0, 0, I can go back to the original inequality. I'm going to go right back here. So 2 times 0 plus 4 times 0 is that less than 8. So we end up with 0 is less than 8, and that's true. Okay, so when we shade that side of the line, it's going to be where the 0, 0 is. Okay, so there's our shading. All right, so go ahead and try 37B, okay, and we will post the homework answer key. All right, thanks. Bye.